So I thought I'd just record a solution to this loan repayment question that turns up in exercise 1D, question 6. Because these are complex questions. These are difficult. All right, I don't expect anyone to be able to just rock up and do these. So because the structure of them is very foreign, I think. Okay. I rushed through in the last few minutes of class just to try and give maybe one or two of you an opportunity to get started on the question and perhaps get through it. But I really concede that wouldn't have been nearly enough. So, but this is the frustration of what we're doing at the moment. But hopefully, I'll send this link out. Hopefully, you get this and this helps. So, and again, I don't. This is not going to make you an expert at it, but it's just going to give you a little exposure so you can see how a geometric series application works. And this is a fairly, I would say, typical type of question to do with applications. Okay, so we've got a $1,500 loan. Okay, the interest rate is 12%. That's per annum, and the loan's to be repaid in 2 years. But the interest is calculated monthly. So the first thing we're going to need to do is come over here and say 12% per annum equals 1% per month. Because what we want is the interest rate per compounding period. Okay, so what the structure is that we want to work out calculate the amount that he has to pay each month. The amount that he has to pay each month if the first repayment is made 1 month after the money is borrowed and after interest is calculated. Okay, so these questions are best attempted by having a amount owing statement. Amount owing after 1 month. Now, the amount owing after 1 month will be 1,000, was it 1,500? Yep, 1,500. He pays his 1% interest on that for the month, right? And then he pays his monthly repayment, right? That's the monthly repayment, and that's what we're trying to find. So that's M. We don't know what that is, but we do know that he owes 1,500 and that each month he pays interest on that. So you can imagine this guy taking the 1,500, the bank charging this 1% interest, and that's how we calculate that. And then at the end of the month, it's almost chronological from left to right. At the end of the month, M's taken out, whatever M is. Okay, so that's all there is. That's the amount owing after 1 month. Now consider that amount and take it into the second month. Amount owing after 2 months. So the amount owing after 2 months is going to be all this 1,500, 1.01 minus M, I'm going to leave it all unsimplified. That all gets charged interest at 1%. And then, so that's now what's owing right at the end of the second month, just before the repayment of M dollars, and then he repays the M dollars. So that needs simplifying, which I might go over here and do that. So that's 1,500 by 1.01 squared minus, I'm going to put an M there, 1.01, if you can see what I'm doing here, distributing that 1.01 out, and then there's a minus M on the end, so I'm just going to put a plus 1 there, because that there accounts for the minus M. So hopefully you can see how that plays out. And the reason I've done it like this is because I've done this sort of question before, and I know how I want it to look, and that's the advantage I have over you very good mathematicians, but just having not seen this before. So after 3 months. Now, all right, let's go again. We're going to take this figure here. We're going to multiply it. So all of that, we're going to multiply it by 1.01, and then we're going to subtract M. All right, this is what we're going to do. This is the pattern. Okay, so I'll just get rid of that because that's making a mess of things. I'll rewrite it. 1500. 1.01 squared minus m 1.01 plus 1. Take all that. Charge interest at 1%, and then finally take out the next month's repayment. Okay, so let's have a look at this. Simplified. I'm going to go down now because I think it's going to be easier to follow. So let's distribute. All right, I've got distribute means just expand, right? So that first, give myself a bit more space. That first is going to get me 1,500 by 1.01 squared times 1.01, which is 1.01 cubed, right? So that's that bit done. All right, the next bit is I've got a few terms in here, haven't I? I've got this minus 1.01 m times 1.01. Right, so that is actually minus m 1.01 squared. So I'm hitting buttons here that, sorry about that, inadvertently hit Skype for Business and took me a while to shut it down. Okay, so I've now just distributed this negative m by 1.01 by 1.01. Now I need to distribute minus m times 1, which is minus m times 1.01. So that's minus m 1.01. I hope you agree. So that's this by this by this, minus m by 1.01. And finally, minus m on the end. Now this is going to take out my common factor of m here, and we can improve on this. 1,500, 1.01 cubed, that's not changing. But here I'll have a nice little geometric sum emerging, I think you'll agree, if I factorize the m out. Okay, it's a geometric sum that is reducing, so we're multiplying by 1.01 to the negative 1 each time. I'm going to reverse the order of that in the next step, right? So the amount owing now, I'm going to project. I think I've got enough information. I see how this is working through. If I multiply that by 1.01 and then subtract another m, all it's going to change is that's going to go to 4, that's going to go to 3, and these are going to reduce by a power of 1 all the way down to 1. So I get how this is rolling out. Okay, so I'm going to now project to amount owing after 24 months. Okay. Now, all right, so at any stage in this video, if you feel like you've got the hang of it and you want to pause me and jump ahead, that's to your benefit. Okay, 1,500. I can see that this is going to be, sorry, that's 1.01 to the power of 24, because I've noticed that this power and this always match up. I've also noticed that this power here and this power here have a difference of 1. So I'm going to use that pattern in my next piece of work. M comes out and I have 1.01 to the power of 23 plus 1.01 to the power of 22, and that's going all the way down to 1. Okay, that's what it's going to look like after 24 months. I'm going to reverse this order. Now, you'll see, really, I don't need to, but it just makes it easier to work with. So I've just reversed the order like so. Now I've got a positive value, sorry, a positive index value for my my common ratio. So this is where the geometric sum, and this is why we're talking about this sort of question in this unit of work, because that's a geometric sum. So I have a geometric progression here where u1 equals 1, my common ratio is equal to 1.01, and I have 24 terms. I can calculate this. I have a sum for this. All right, and it is, so the sum to 24 terms with this information is U1 by R to the N minus 1 over R minus 1. So this simplifies to 1.01 to the 24 minus 1 over 0.01. And actually dividing by 0.01 is the same as multiplying by 100, isn't it? Top and bottom by 100. So I end up with 100 by 1.01 to the power of 24 minus 1. And pop that in brackets. Okay, so that there is the sum of what's in the brackets there outside my M. So therefore, I've got a new and improved statement here for my amount owing after 24 months. It's 1,500 by 1.01 to the power of 24 minus M by 100 minus, sorry, not minus, by 1.01 to the power of 24 minus 1. Close, close. Okay, so that's all very good, but what's that going to be equal to? So now we need to just understand what the question's asking, really, and that is the amount that Gi-hun has to pay each month. The first repayment, the loan is to be, this is the crucial bit here, the loan is to be repaid in 2 years. So this repayment amount, the amount owing after 24 months, this has to equal 0. I'm going to put that in red because that's super important. Equals 0. Has to be repaid. All right, repaid in full. After 2 years. They're the terms of the loan. So this is what we are challenged here to do. We're here to find M such that this statement here will come to 0 after 24 months. So now we just solve for M. Therefore, what do we got here? Let's get M on one side. So M by, I'm sure you guys can go ahead and do this bit on your own, is equal to this. And so therefore M will be equal to this quantity over this quantity. And that, I think, gets us $70.61. And so that's the monthly repayment. So therefore, monthly repayment is $70.61. Now, there was another question. Varied how much to the nearest dollar? Make sure that's okay. Gi-hun actually has to pay for finishing the apartments. What that means is he's paying that each month. So he's doing that for 24 months. So if you multiply that by 24, I think we get 1695. So therefore, actual cost, if that's the wording, value how much he actually has to pay for finishing the apartment. Actual cost of furnishing is equal to $70.61 times 24, because he makes 24 of those repayments. I think we get 1695, which looks about right. He borrowed $1,500 so that he could get the furniture immediately. So the cost of that is that over 24 months, it costs him $1695. So he pays an extra $195 in rent. And that's the question. It would be good for you to practice another question like this. They're quite time consuming, but I'll see if I can dig one out. Okay, here's one for you. $10,000 loan, paid off, same sort of question, paid off in monthly installments over 5 years. Here's our interest rate per annum. Remember, you need to change that to per month. Find the monthly repayment and the total amount of interest paid over the 5 years. Okay, have a go at that question, and I will give you the answer. I'll give you the answer to that in the next 24 hours or so. Okay, cheers.